In the outskirts of our solar system, where sunlight fades into a dim whisper and shadows stretch for eternity, there drifts a world of ice and silence. Pluto, a name that once conjured images of darkness and myth, now exists as both a scientific enigma and a poetic symbol of isolation. Out here, nearly 6 billion kilometers from the warmth of the sun, the laws of familiarity dissolve, time slows, light takes hours to arrive. And in this cold, slow universe, Pluto moves in quiet defiance, holding secrets as ancient as the solar system itself. Its orbit is not graceful. It loops and tilts at strange angles, as if refusing the order of planets closer to the Sunday. Where Earth's path is neat and circular, Pluto's is eccentric both literally and mathematically. It crosses inside Neptune's orbit at times, breaking the unspoken symmetry of the planetary family. Yet, it continues its lonely pilgrimage, one complete journey taking 248 Earth years. Every human civilization, from the dawn of agriculture to today's digital age, would experience only a fragment of a single Plutonian year. Imagine standing there, if one could stand at all, on a surface coated in nitrogen frost and methane snow. The air is so thin it barely qualifies as an atmosphere. Each step would crunch softly over frozen plains, where temperatures plunge to 230 degrees Celsius. Above, the sun would hang like a pale star, its light barely enough to cast a shadow. The horizon glows faintly blue, a haze suspended in perpetual twilight. It feels like standing on the edge of creation itself, looking outward into the unknown. Pluto's world is not simply dead rock, it is a monument to endurance. Despite its remoteness, despite its demotion, despite centuries of cosmic neglect, it continues to capture our imagination. For in its icy heart lies something deeply human, the yearning to belong, to be seen, to be understood. When we gaze toward Pluto, we are not just looking at a planet or an explanet. We are looking at the limits of our reach, the boundaries of warmth and life. It is a mirror for loneliness on a cosmic scale, a place that, by its very existence, asks whether the universe remembers its forgotten children. The Kuiper Belt, Pluto's home, is a realm of fragments. Here orbit billions of icy bodies, remnants from the dawn of the solar system. These are cosmic fossils, pieces of the same cloud of dust and gas that gave birth to the planets. Pluto is the largest among them, but even it is just one shard in a celestial graveyard. The light here is not golden, but blue and cold, refracted through methane crystals and nitrogen frost. The silence is absolute. And yet, there is motion. Pluto's surface is not still. It breathes, it shifts, it changes over time. Beneath that distant frost, hidden mechanisms stir a faint internal warmth, perhaps generated by radioactive decay. Scientists have seen signs of flow, of renewal. They have seen the faint gleam of a glacier in motion, the rise of mountains carved from water ice. In the poetry of the cosmos, Pluto is the stanza that lingers. It doesn't shout like Jupiter or blaze like Venus. It whispers, and in its whisper, we hear the universe confess something rare, that even in exile, beauty persists. For millennia, this world went unseen. Its light, faint and stubborn, reached Earth as a flicker too weak for the naked eye. Ancient astronomers could not have imagined its existence. It waited silently in the dark, watching humanity grow from stargazers to explorers. It would take the birth of modern science, the invention of precise instruments, and the tireless patience of one young man in a quiet observatory to finally draw Pluto out of obscurity. Before its discovery, there were only suspicions, hints, that something unseen tugged gently at Neptune's orbit, as if an invisible hand lingered beyond the known planets. Astronomers called it Planet X, a mystery waiting just beyond the horizon of knowledge. And so begins the story of Pluto, not merely as a frozen sphere of ice, but as a cosmic question that has haunted generations. What lies beyond the edge of the sun's domain? How far does our story stretch before it fades into silence? Pluto stands as an answer and a riddle, a reminder that even in the farthest corners of the void, there are worlds that shimmer softly in defiance of darkness. Worlds that hold their secrets close, waiting for the patient gaze of a species that dares to look beyond itself. And as the faint sunlight glints off its frozen plains, as its thin haze catches the starlight in hues of sapphire and silver, Pluto continues to drift steady, unhurried, and eternal. It was February of 1930 when the silence of the outer solar system was finally broken by human eyes. In a small observatory in Flagstaff, Arizona, a young astronomer named Clyde Tombaugh sat hunched over a blink comparator, a mechanical device that flickered between two photographic plates of the same region of sky. Night after night, he scanned for movement, searching for the faint motion of a celestial ghost. The Lowell Observatory was perched high in the desert, under skies so clear they seemed to stretch into eternity. The project Tombaugh inherited was not his own. It had begun decades earlier with Percival Lowell, the wealthy founder of the observatory, who was obsessed with the idea that an unseen Planet X lurked beyond Neptune. Lowell had died in 1916, still searching, leaving behind his equations, his passion, and a telescope aimed at the stars. Tombaugh, just 24 years old and self-taught in astronomy, was given the task of continuing the hunt. For months, he examined thousands of star fields, comparing photographs taken days apart, each time hoping to see one tiny dot that shifted a world in motion against the fixed constellations. It was grueling work, monotonous and eye-straining. The faint specks of dust and scratches on the glass could easily deceive even a careful observer. Then, on the 18th of February 1930, the pattern changed. On the glass plates dated January 23 and January 29, a single light moved slightly, unmistakably. Tombaugh leaned closer, adjusting the comparator. He blinked again. The tiny dot had shifted positions. There it was, a world in the making, a motion among stillness. After 15 years of speculation, Planet X had a face. The news spread like wildfire through scientific circles. Newspapers called it a triumph of human curiosity, a discovery born from patience and vision. The world that had remained hidden for billions of years was finally seen, a small point of light in the vast abyss. It was quickly named Pluto, after the Roman god of the underworld, both a tribute to the dark realm it inhabited and a nod to its mysterious, distant nature. But there was another reason behind the name. Venetia Burney, an 11-year-old schoolgirl in Oxford, suggested it at her breakfast table after reading about the new discovery. The name carried a quiet poetry that resonated with scientists. It began with P, honoring Percival Lowell, whose initials could now live on in the symbol. And so, from the imagination of a child and the dedication of a dreamer, Pluto entered our shared celestial story. For the first time, humanity's map of the solar system extended beyond Neptune. A new world had joined the family, small, dim, but undeniably real. The telescopes of the time revealed little more than a faint dot, but to the astronomers of the 1930 seconds, it was enough to spark wonder. Pluto seemed to embody the spirit of discovery itself, hidden, patient, and waiting. And yet, even in that moment of triumph, questions began to emerge. Was this the world Lowell had predicted? Could something so small exert the gravitational pull he had calculated? Pluto's faint brightness suggested it was much smaller than Earth, perhaps even smaller than the Moon. The numbers didn't match, and doubt crept in. But it didn't matter for the time being, the mystery was enough. As the years passed, astronomers peered deeper, trying to learn more. Pluto's orbit, its faint glimmer, its distance, everything about it defied the patterns of the known planets. It was tilted, stretched, unpredictable. Unlike the serene circular dance of the other worlds, Pluto wobbled and weaved, cutting inside Neptune's orbit for nearly 2 decades at a time. To understand, it required more than mathematics. It required imagination, the willingness to accept that the solar system was not as neat as we once believed. In that distant discovery, science encountered something humbling, the realization that our model of the universe was incomplete. For Toombor, the moment marked the culmination of human persistence. In an era before computers, before digital sensors, he had found a world by sheer will, by the power of eyes and patience. The plates he used, fragile glass negatives capturing photons from a distant sun, remain to this day as silent witnesses of that discovery. And in a cosmic sense, the finding of Pluto was less about expanding the solar system and more about expanding the human heart. It showed that even in the coldest corners of space, the universe could still surprise us. It reminded us that the cosmos is not fixed, it evolves, it hides, it waits for us to notice. By the 1950 seconds and 60 seconds, as technology advanced, telescopes revealed more about Pluto's faint light curve. Astronomers realized it was not alone that it had a moon, Charon, discovered in 1978. The discovery of Charon would eventually help us measure Pluto's true mass and reveal the shocking truth: it was far too small to have perturbed Neptune's orbit. Lowell's Planet X had never existed. Pluto was something else, entirely a wanderer, an orphan world, a survivor from a forgotten age. But the emotional resonance of its discovery remained. In the dim red glow of Flagstaff's observatory, Clyde Toombor had glimpsed not just a planet, but the edge of human possibility. Beyond that point, there was only speculation and starlight. Pluto's arrival into human awareness marked the beginning of a new kind of astronomy, one that stretched beyond imagination toward the icy limits of our sun's reach. It was the discovery of solitude itself, written in orbit, frozen in time. And though the decades ahead would challenge its status, its name, and its very definition, Pluto's discovery would stand forever as a testament to what happens when curiosity refuses to rest, when even the smallest flicker of light in the darkness becomes a story worth telling. In the years following Pluto's discovery, a subtle unease began to ripple through the astronomical community. The world that Clyde Toombor had revealed was beautiful, yes, but it did not fit. Its orbit was unruly, its size was disappointing, and its mass, once thought to rival Earth's, turned out to be minuscule. The solar system, long believed to be a clockwork of precision and predictability, had gained a misfit. Pluto's light was dim and erratic. Observers realized that its brightness varied over time, as if the little world rotated an uneven face toward the Sunday. It reflected sunlight off patches of nitrogen frost and dark organic tholins, pigments formed from cosmic radiation. This alternating brightness hinted at a surface unlike any other known planet, fractured, patchy, alien. But there was something else, too. The orbit itself. Where the other planets circled the Sun along a flat, nearly shared plane, Pluto's path was tilted by an astonishing 17 degrees. It moved in a lopsided ellipse, sometimes closer to the Sun than Neptune, sometimes far beyond it. For 20 years of its 248-year journey, it crossed inside Neptune's orbit, as though defying celestial order itself. To early astronomers, this was a puzzle bordering on blasphemy. How could a planet behave so badly? The answer would not come easily. For decades, Pluto was the solar system's smallest and most distant planet, a title that carried both prestige and suspicion. Its erratic orbit seemed to mock the mathematical harmony that had guided science since Newton, and yet there it was, real, faint, enduring. Scientists tried to explain away the oddities. Some proposed that Pluto might be a captured moon, torn from Neptune's gravitational grasp in some violent cosmic encounter. Others speculated it could be a survivor from a lost world, a remnant of early chaos when the planets collided and scattered, but no model fit perfectly. Then, in 1978, everything shifted again. Astronomer James Christie, studying images of Pluto through a telescope at the U.S. Naval Observatory, noticed something peculiar, a small bulge on one side of the planet that seemed to move. After meticulous analysis, he confirmed what seemed impossible: Pluto had a companion. He named it Charon, after the ferryman who carried souls across the river Styx in Greek mythology. Charon's discovery would forever change how we understood Pluto. With it, scientists could finally calculate Pluto's mass, and it was far smaller than imagined. Combined, Pluto and Charon had a fraction of Earth's mass, less than 1/5 of our moon. Planet X, it seemed, was a phantom. What emerged instead was something far stranger, a binary world. Pluto and Charon did not orbit in the traditional sense, where one dominates the other. They spun together around a shared center of gravity, located in the empty space between them, a cosmic duet rather than a hierarchy. No other planet-moon system in the solar system behaved like it. It was as if the cosmos itself refused to let Pluto belong neatly anywhere. Not quite a planet, not quite a moon. It hovered between definitions, a reminder that the universe does not bend to human categories. And as telescopes improved, more peculiarities surfaced. Pluto's atmosphere seemed to grow and shrink with its distance from the Sun, evaporating under weak warmth and freezing back onto the surface during its long winters. Its light curve, that pulse of brightness and shadow, became a symbol of its rhythm, a heartbeat echoing faintly across billions of kilometers. Astronomers began to see Pluto less as a planet among planets and more as a world apart, a window into the early solar system. Perhaps, they thought, Pluto was a survivor from a time before order, a remnant from the era of collisions and chaos. Its orbit told the story of violent gravitational battles with Neptune, ejections from protoplanetary disks, the scattering of icy debris to the Kuiper belt. The more scientists learned, the more they realized Pluto was not alone. In the late 20th century, telescopic surveys began to uncover other bodies orbiting beyond Neptune, small, icy worlds on eccentric paths. One by one, they appeared: Quaoar, Sedna, Eris. Suddenly, Pluto's uniqueness was in question. The Kuiper belt, once only a theory, became a populated frontier. Eris, discovered in 2005, was nearly the same size as Pluto, perhaps even slightly larger. Its presence forced astronomers into an uncomfortable reckoning. If Pluto was a planet, then Eris must be one too. And if Eris qualified, what about the hundreds, perhaps thousands of other Kuiper belt objects waiting to be found? For decades, Pluto had been the edge, the last known world, the symbol of the frontier. Now, it was just one among many. The myth of the ninth planet began to dissolve under the weight of new data. Yet, even as its status was challenged, Pluto's allure deepened. It had always been a rebel, an outlier, a wanderer. Its defiance was written into its orbit. And so, the story of Pluto became not one of demotion, but of redefinition. It forced humanity to confront an uncomfortable truth that the universe is far more complex than our need for order allows. What we call planets are but a subset of endless forms, and our labels are merely fragile attempts to impose meaning on the infinite. In that sense, Pluto's misfit nature became its greatest triumph. It refused to conform, reminding us that science, like the cosmos itself, thrives on uncertainty. When we look at Pluto's uneven orbit today, we do not see chaos. We see memory, the ancient scars of formation, the dance of gravity and time, the persistence of an object that has witnessed 4 billion years of cosmic evolution. Its tilted path is not an error, it is a signature, a mark of survival. Among the giants of the solar system, Jupiter, Saturn, Neptune, Pluto remains a whisper. But that whisper carries the echo of the universe's first breath, and the faint promise that even in irregularity, there is profound beauty. When the announcement came in August of 2006, it did not echo through laboratories or observatories, it reverberated through hearts. After 76 years of planetary dignity, Pluto had been stripped of its title. The International Astronomical Union, meeting in Prague, voted to redefine what it meant to be a planet, and by that new definition, Pluto no longer qualified. The decision seemed clinical, a matter of scientific housekeeping, but to millions around the world, it felt like exile. Pluto had become a beloved symbol, a small, lonely outpost that carried our curiosity to the edge of sunlight. Now, it was being demoted to a dwarf planet, a term that sounded faintly dismissive, almost cruel. Teachers updated charts, textbooks were rewritten, but something deeper stirred in the collective imagination. Why did it matter so much? Why would humanity care about a frozen rock 6 billion kilometers away? The answer lies not in logic, but in identity. Pluto had been our gateway to mystery, the last stop before the void. To remove it from the pantheon of planets felt like removing the frontier itself. The debate that led to the demotion began decades earlier, in the growing recognition that Pluto did not behave like the others. Its orbit was eccentric, tilted, and far smaller in mass than any true planet. Then came the discovery of Eris, an icy world almost identical in size but lying even farther out. Astronomers faced a dilemma: either the solar system contained hundreds of planets, or the definition had to change. At the heart of the debate was one question: what makes a planet a planet? The answer, it turned out, was less cosmic and more philosophical. A planet, the IAU declared, must meet 3 criteria. It must orbit the Sun, be massive enough for its gravity to make it nearly round, and it must have cleared its neighborhood of other debris. Pluto failed the third. It shared its space with countless icy bodies in the Kuiper belt, moving among them rather than dominating them. And so, with a vote of a few hundred astronomers, many of whom were not planetary scientists, Pluto was reclassified. It was a moment of bureaucratic precision that masked a profound emotional rupture. For every scientist defending the decision, there was another questioning its meaning. Alan Stern, principal investigator of NASA's New Horizons mission, called the ruling absurd. "Pluto is more dynamically interesting than any planet I know," he said. "It's alive with activity. That's what matters." Indeed, science had never before seen such public attachment to a world so distant. Newspapers filled with essays and editorials, children wrote letters begging for Pluto's reinstatement, even late-night comedians mourned its fall. For a generation raised under posters of 9 planets, the universe suddenly felt incomplete. But beneath the sentiment, the debate forced a rare kind of introspection, one that science often resists. It asked, what are definitions worth in a cosmos that refuses to stay still? Is a planet a category or a story? Perhaps Pluto's demotion was less a scientific downgrade than an evolution of perception. By removing it from the list, astronomers inadvertently freed it from comparison, from hierarchy, from expectation. It became something purer, a world defined not by size or power, but by mystery. And yet, for those who studied it, the scientific questions only grew. If Pluto was not a planet, then what was it? Its composition suggested a mixture of rock and ice, not unlike the moons of the outer planets. Its orbit hinted at ancient chaos, a relic from the solar system's early years. Maybe, scientists thought, Pluto was a survivor from the primordial disk that once encircled the Sun, an ancient shard from a time when collisions and migrations sculpted the worlds we know. In this sense, Pluto's demotion became a revelation. It revealed the boundaries of our knowledge and our language. The solar system was not a neat hierarchy of 8 perfect spheres. It was a sprawling, evolving system of bodies large and small, bound together by gravity and chance. The line between planet and not planet was arbitrary, drawn not by nature, but by human need. Still, the emotional sting lingered. Even years after 2006, Bring Back Pluto campaigns continued to appear. For many, the issue was never about science, it was about belonging. We had named this world, explored it with our minds, and projected our longing for discovery onto its frozen face. To see it reduced to a footnote felt personal. But Pluto, characteristically silent, did not protest. It continued its orbit, slow and patient, indifferent to human categories. The universe does not mourn, it endures, and so did Pluto. In the years following the demotion, something unexpected happened. Interest in Pluto surged. Far from being forgotten, it became more intriguing than ever. Scientists, poets, and dreamers alike began to see it not as a lost planet, but as a key to something greater, the bridge between the orderly solar system and the chaotic beyond. The debate, in retrospect, was not an ending, but a beginning. It signaled a new era of exploration, one that would soon culminate in the arrival of a spacecraft designed to uncover Pluto's truth. And when that spacecraft finally reached it, nearly a decade later, the universe itself seemed to whisper an apology for what was lost in names would be redeemed in wonder. Far beyond Earth's orbit, past the gas giants and their swirling storms, there lies a silent heart frozen into the surface of a distant world. It gleams faintly beneath the dim sunlight, a vast, icy basin shaped uncannily like a human heart. Astronomers would later name it Sputnik Planitia, but to those who saw it for the first time, it looked like a message written in frost, a cosmic symbol beating faintly in the dark. In July 2015, when NASA's New Horizons spacecraft swept past Pluto, this heart became its most haunting image, a white expanse of nitrogen ice spanning over 1,000 kilometers, bordered by jagged highlands and shadows that hinted at movement beneath the surface. It wasn't just beautiful, it was impossible. Pluto, scientists had believed, was a dead world, frozen, ancient, geologically inert. But the heart told another story. Its surface was smooth, unscarred by impact craters, suggesting youth. It had been renewed not billions of years ago, but perhaps only a few million. For a world so far from the sun, such activity should not exist. Yet there it was, a frozen heartbeat in the dark, defying thermodynamic expectations. Sputnik Planitia lies within a massive depression, likely formed by a cataclysmic impact eons ago, but instead of lying dormant, it seems alive with motion. Nitrogen ice, soft and flowing like cold taffy, slowly convects, warm ice rising, cool ice sinking, creating a pattern of cellular ridges across the surface. These cells shift over millennia, giving Pluto's heart a living texture, like the faint pulse of an organism breathing in its sleep. Deep below, there may be warmth. Computer models suggest that Pluto's interior retains enough radioactive heat to maintain a subsurface ocean of water mixed with ammonia antifreeze for the cosmos. That buried ocean could provide the buoyancy that keeps Sputnik Planitia low and even drive the convection that reshapes its surface. In this vision, Pluto is not merely frozen, it is dreaming, alive beneath its crust, its heart stirred by ancient heat. the heart's western lobe, bright and reflective, contrasts sharply with the darker terrains that surround it, regions named Cthulhu Macula and Kroon Macula, their surfaces coated in reddish tholins, created when ultraviolet light and cosmic rays strike methane ice. The juxtaposition is mesmerizing, half world of death, half world of rebirth. This duality, the gleaming plains of Sputnik against the ancient scars of Cthulhu, tells a story of contradiction, of a world that should have gone silent but instead found ways to whisper. The convection cells, hundreds of kilometers wide, move slowly, perhaps a few centimeters per year, but over geological time, they can erase the marks of craters. In a way, Pluto heals itself. The very idea unsettles and inspires. How could such a small body, distant and cold, still possess enough internal heat to sculpt its own landscape? The answer lies in the physics of decay, not of life, but of matter. Radioactive isotopes like uranium, thorium, and potassium within Pluto's rocky core release energy as they transform, a steady trickle of warmth over billions of years. It's not much, but in a world wrapped in insulation, where heat escapes reluctantly through layers of ice and nitrogen frost, it's enough to keep the heart alive. To scientists, this discovery redefined the boundaries of geological vitality. It proved that life, or something resembling life, could exist in the absence of sunlight. In Pluto's faint pulse, they saw echoes of Enceladus and Europa, the icy moons of Saturn and Jupiter that also hide oceans beneath their frozen shells. The pattern was unmistakable. The solar system's outer darkness is not dead, it hums with quiet, hidden energy. The shape of Sputnik Planitia itself may not be accidental. Its alignment suggests a gravitational balancing act with Charon, Pluto's companion moon. Some scientists believe the basin's weight caused Pluto to roll slightly over time, reorienting itself so that the heart now faces directly towards Charon, as if locked in an eternal gaze between two ancient lovers orbiting each other in slow, perfect rhythm. It's a poetic image, but the physics behind it is profound. This reorientation would have required a subsurface ocean to act as a lubricating layer, allowing the crust to shift, further evidence of something alive beneath the ice. When New Horizons transmitted these images back to Earth, they arrived pixel by pixel, traveling over 4.5 hours at the speed of light. In that cascade of data, humanity saw not just a frozen wasteland, but a pulse, a sign that even the most remote world could surprise us with vitality. The heart became a symbol of defiance, a beacon of persistence in a place where heat should die and time should stop. It reminded us that even in the farthest reaches of the solar system, complexity thrives, beauty emerges, and motion never truly ceases. On Earth, people wept over the images not because they had found life, but because they had found meaning. A frozen world, exiled from the ranks of planets, had revealed a heart that beat in slow, silent rhythms of ice and light. In that moment, Pluto became something greater than a planet. It became a metaphor for endurance, for mystery, for the quiet persistence of wonder in the face of cold oblivion. And as scientists continued to study its shape, its texture, and its movement, one truth emerged like a whisper. From the void, the heart of Pluto does not simply exist, it endures. From the distance of Earth, Pluto's surface may seem still an unchanging tundra of frozen nitrogen and methane. But when New Horizons slipped past it in 2015, the truth revealed itself: Pluto breathes. Its tenuous atmosphere, delicate and transient, is not fixed but alive, expanding and collapsing in slow rhythm with its orbit, like lungs inhaling and exhaling over centuries. The air is almost non-existent by human standards, a whisper of nitrogen, laced with traces of methane and carbon monoxide. Yet in Pluto's thin gravity, Even this fragile veil performs miracles. When sunlight touches the surface, nitrogen ice sublimates, rising into the sky to form an atmosphere that can extend hundreds of kilometers above the ground. When Pluto drifts farther from the sun, the chill returns and the air collapses, freezing out, molecule by molecule, falling like snow to the plains below. This breathing cycle, invisible to the naked eye, is a masterpiece of equilibrium. It transforms Pluto into a living world of motion, even in the near absence of heat. Instruments aboard New Horizons detected layers upon layers of haze, more than 20 distinct strata suspended like translucent curtains in the sky. Sunlight filtering through these layers revealed a pale blue halo around the planet, astonishing scientists who expected darkness. That blue, delicate and faint, is not the color of oceans or air. It is the hue of scattering the same physics that paints Earth's sky, recreated in miniature at the edge of the solar system. Tiny particles, only a few hundred nanometers wide, deflect sunlight in the short wavelengths of blue. These particles, called tholins, are born from ultraviolet radiation striking methane, breaking it apart and rebuilding it into complex organic molecules. Pluto's blue haze, therefore, is not just beauty, it is chemistry made visible. Each layer tells a story of sunlight colliding with methane, of atomic fragments bonding and reforming into carbon chains that drift downward, settling eventually onto the surface as a faint reddish dust. Over millions of years, these organic films stain the ice, giving Pluto its patchwork tones of copper and cream. This interaction between light and matter transforms Pluto into an artist's canvas. Its thin atmosphere is both sculptor and storyteller, weaving invisible cycles between surface and sky. Even as the sun's warmth ebbs and flows across its elongated orbit, Pluto maintains this breathing rhythm, a balance so delicate that a small change in temperature could tip it toward permanence or extinction. Scientists studying these processes began to realize that Pluto's atmosphere behaves less like that of a frozen moon and more like that of an active world. It has winds, albeit faint ones, driven by temperature gradients across its plains. These breezes, flowing gently from the illuminated regions toward the shadowed heart of Sputnik Planitia, help redistribute nitrogen frost, giving the surface its dynamic sheen. Imagine standing on Pluto's plains, watching the horizon shimmer in the thin blue light of a distant Sunday. The air would be silent, but it would move a whisper brushing against your visor. Above, layers of haze would glow like gauze, fading from cobalt to rose as the sun sank behind the horizon. The temperature would plummet, and with it, the sky itself would begin to fall, the air freezing, settling, reclaiming the ground. To scientists, this fragile cycle is not merely atmospheric mechanics. It is a profound symbol of resilience. Even at the edge of the sun's reach, where heat is nearly extinguished, matter finds a way to move, to exchange, to transform. In that motion lies the faintest echo of life, not biological, but existential. A reminder that nothing, not even the most distant world, is ever truly static. As Pluto's orbit carries it away from perihelion, the closest point to the Sun, its atmosphere begins to thin. Some models predict that, over the coming decades, it may vanish entirely, freezing solid on the surface until its next close approach, centuries from now. Yet others suggest the heart of Sputnik Planitia, with its internal warmth, may keep parts of the cycle alive, a persistent pocket of vapor rising and falling even in the coldest years. If true, then Pluto's breath never fully stops, it only slows. This discovery reframed how scientists think about active planets. Activity, they realized, need not roar like volcanoes or storms, it can whisper. The expansion and collapse of Pluto's atmosphere, its exhalation of sunlight, its inhalation of shadow, is an act of endurance on a cosmic scale. New Horizons captured images of this ephemeral world in twilight. The probe's cameras, turned back toward the fading sun after its closest pass, recorded something extraordinary, a backlit silhouette of Pluto, rimmed with blue. The haze extended higher than anyone expected, cascading into space in faint, layered arcs. It was as if the planet glowed from within, illuminated not by heat but by memory. The data revealed that the haze particles eventually fall, drifting through the air for months or even years before settling. Over time, they paint the landscape with the same reddish compounds that define the color of distant comets and moons. Pluto, in essence, is constantly remaking itself, breathing, shedding, and being reborn through chemistry. When the images first appeared on earthly screens, they evoked awe and melancholy in equal measure. That blue glow, distant, fragile, and haunting, seemed to embody everything that Pluto had come to represent. It was the color of mystery, of endurance, of quiet rebellion against the void. In the silence of space, far from the warmth of any sun, Pluto continues to inhale and exhale its frozen air. Its atmosphere is a ghost, a wisp of life in a realm that should know only death. And yet, it moves softly, eternally, a breath no less real for being unseen. In the pale light of the distant sun, Pluto's surface rises and falls like a frozen ocean caught mid-wave. Its landscapes are not gentle slopes or simple plains, but sculpted cathedrals of ice, mountains higher than the Rockies, ridges as sharp as knives, valleys carved by invisible winds. The mountains themselves are not made of rock, but of water, ice as hard as granite. Under those temperatures, their peaks glinting with methane frost. When New Horizons transmitted its images back to Earth, scientists stared in disbelief. Pluto was supposed to be small, inert, and dead. Instead, it was majestic. Vast ranges like Tenzing Montes and Hillary Montes, named for the first conquerors of Everest, soared up to 3,500 meters above the plains. But these were not rocky summits born of magma and pressure. They were frozen monuments, their foundations sculpted by time and sublimation, the slow exhalation of volatile ices that shaped the surface grain by grain. Each peak on Pluto tells a story of defiance. These are mountains that should not exist, relics of an interior strength, frozen in motion. Beneath their slopes, nitrogen glaciers crawl across the plains of Sputnik Planitia, flowing into dark troughs and rifts like the veins of an ancient, breathing body. Where Earth's glaciers carve by melting, Pluto's move by sublimation ice, transforming directly into vapor, migrating, reforming, and flowing again. And yet, the stillness of these ranges hides violence. The contrast between regions from the bright plains of Sputnik to the blackened stretches of Cthulhu Macula suggests cycles of frost and release, of freeze and thaw driven by Pluto's long, elliptical orbit. For centuries, as it swings closer to the sun, Pluto's frozen gases awaken, painting the mountains with frost. As it drifts back outward, the frost retreats, leaving scars of sublimation and dark deposits that trace its breathless seasons. No human could stand on these peaks without seeing eternity. The horizon would curve gently under a black sky where the sun glimmers like a faraway lantern. Charon would loom huge, half the width of Earth's moon, but much closer, suspended above the frozen plains, locked forever in place. Shadows would stretch for kilometers, their edges softened by the faint blue haze of the atmosphere. Every sound would be muffled by the thinness of the air, and every movement, slow, a ballet performed in near weightlessness. Scientists studying these landscapes noticed something even more extraordinary. The ice composing these mountains is predominantly water H2O, but capped by methane frost that shimmers under weak sunlight. Methane, though fragile in Earth's warmth, behaves like stone here, depositing in layers across the ridges and summits. These frosted caps glint faintly in the light, marking the highlands like patches of snow on earthly peaks. The presence of methane and nitrogen in these patterns reveals a complex climate system where vapor condenses and freezes in predictable cycles. It is a form of weather, though slowed to an unimaginable pace, storms that last centuries, frostfalls that creep rather than descend. Pluto's mountains are not geological fossils. They are living monuments, eroded and renewed in the rhythm of cosmic breath. The imagery that New Horizons returned told stories the instruments could not yet explain. Vast polygonal cracks cut across the plane's frozen convection cells where nitrogen ice churns beneath the surface. To the south, immense dark regions stretch for thousands of kilometers, stained by tholins and organic compounds formed in the upper atmosphere. These methane shadows, as some scientists call them, absorb sunlight and accelerate sublimation, deepening their color with every passing keon. In these shadows, the mystery of Pluto's surface deepens. It is a world of paradox where sunlight, weak but persistent, sculpts ice as if it were clay, where heat from below, though almost gone, drives glaciers to flow across the frozen plains, and where light and darkness carve symbols onto the face of a planet that refuses to die. At the boundaries of these landscapes, Pluto's crust fractures into canyons, hundreds of kilometers long, cliffs that plunge deeper than the Grand Canyon, carved not by rivers but by expansion and contraction as ice warms and freezes. These fractures hint at internal motion, as though the planet's outer shell flexes over something fluid beneath perhaps that same hidden ocean scientists suspect lies under Sputnik Planitia. If so, then the surface of Pluto is not a static skin but a membrane brittle, yes, but alive with pressure and response. Every mountain, every fissure, every dark stain of methane tells of a conversation between the surface and the deep. It is a dialogue spoken in the language of cold and gravity. Over billions of years, Pluto has found balance between collapse and endurance, between the pull of space and the push of internal heat. The mountains rise not because they are built, but because the ice beneath them resists frozen strength that outlasts erosion, wind, and time itself. Even now, scientists still struggle to reconcile the vigor of these landscapes with Pluto's diminutive size. How can a world so small, with so little sunlight and such weak gravity, sustain geological activity? The answer may lie in the peculiar chemistry of its ices, in the mobility of nitrogen, methane, and carbon monoxide that evaporate, migrate, and freeze in endless cycles, turning Pluto's surface into a canvas of motion painted by temperature and light. To gaze at these ice mountains is to see the universe's persistence made visible. They are monuments to endurance peaks that rise not from fire, but from patience, sculpted molecule by molecule by the slow breathing of the cosmos. And perhaps that is Pluto's most haunting beauty, that even at the edge of sunlight, where warmth fades and night rules, the laws of physics still find ways to create splendor. Its mountains do not shout, they hum, they shimmer in the cold and whisper that motion never ceases, that creation continues even in exile. On Pluto, even the silence builds mountains. There are places in the solar system where two bodies no longer merely orbit, they dance. Among them, none waltz so elegantly as Pluto and its moon, Charon. They are not master and servant, not planet and satellite, but partners in an ancient choreography, two worlds bound by gravity in perfect, perpetual balance. Charon was discovered in 1978 by James Christie, who noticed that Pluto's image seemed to bulge rhythmically in telescope photographs. What he had seen was not distortion but companionship. Charon, nearly half Pluto's size, orbits so closely that the two worlds spin around a shared center of gravity that lies not within Pluto itself, but in the empty space between them. In the cosmic ledger, they are equals a true binary system, locked in gravitational embrace. Together, they orbit once every 6.4 Earth days, each showing the same face to the other, eternally synchronized, eternally gazing. On Pluto's surface, Charon never rises nor sets. It hovers in the same place in the sky, looming large and pale, its craters and chasms visible even from the frozen plains of Sputnik Planitia. To stand beneath that constant companion would be to feel both intimacy and distance, two worlds tethered together across an endless void. Charon itself is a mystery. Its surface is a world of contradictions, vast canyons, fractures, and plains of frozen water and ammonia. A colossal scar, the Serenity Chasma, stretches across its face, dwarfing the Grand Canyon tenfold. It hints at a violent past, perhaps the freezing of an ancient ocean or the cracking of a world still cooling from its birth. The northern hemisphere of Charon is darker, stained in crimson tones, the mark of Pluto's influence. Methane escaping from Pluto's faint atmosphere drifts across the gulf between them, only to freeze on Charon's poles. Ultraviolet light from the distant sun transforms that methane into tholins, the same reddish compounds that give Pluto its hues. In this way, even across 19,000 kilometers of emptiness, Pluto paints its companion. This exchange, faint, invisible, yet eternal, binds them in ways deeper than gravity. The two worlds share not only motion but substance, swapping molecules and light, shaping each other's colors and fates. Where most planets command their moons with dominance, Pluto and Charon exist in equality, each turning in time to the other's pull. In this waltz, there is poetry written in orbital mechanics. Their barycenter, the balance point around which they spin, floats above Pluto's surface like an invisible thread of harmony. It is the mathematical embodiment of partnership, of shared destiny. Their movements are so perfectly tuned that were one to stop spinning, the other's rotation would unravel instantly. But this grace was born of chaos. Most scientists believe that long ago, a massive impact struck Pluto, a collision with another Kuiper Belt object that shattered its crust and hurled debris into space. From that wreckage, Charon coalesced, slowly settling into orbit as the two bodies locked into tidal synchronization. What began in violence became balance. What began in fragmentation became dance. In this, Pluto and Charon mirror the cosmic rhythm of destruction and creation that defines the universe. Stars collapse to form new worlds, galaxies collide and spawn spirals, and from impact comes order. Their duet is not only a celestial curiosity, it is a living reminder that harmony can emerge from the ashes of catastrophe. The gravitational relationship between them also affects their geology. The constant tidal forces, the gentle tug and release of gravity may generate heat within Pluto's interior, keeping its subsurface ocean from freezing completely. Charon, too, bears the marks of internal stretching, the fractures across its surface evidence of expansion as its core cooled and water ice solidified. Their interaction is not passive, it sculpts them both, an invisible hand-etching geometry into the cold. Astronomers once thought of moons as simple companions, orbiting obediently, but Charon refuses that simplicity. It challenges the hierarchy. It turns a lonely planet into a system, a duet that redefines what it means to orbit. Together, they exist as a binary truth that gravity, at its most profound, is not control but connection. When New Horizons flew past in 2015, it captured the first real portraits of this pair. The images stunned the world. Charon's grey plains and black scars contrasted sharply with Pluto's shimmering heart. The two appeared suspended in darkness, like dancers caught mid-step, each reflecting the other's light. Scientists could see in Charon's surface a story written in time. Craters told of impacts, while smooth stretches hinted at resurfacing evidence that even this moon, so far from the sun's warmth, might once have been geologically alive. Its pale expanses of water ice glittered under the weak light, while its polar darkness glowed faintly red, stained by the chemistry of shared atmosphere. In the silence of space, they revolve an endless embrace, so slow and steady that it defies comprehension. For every sunrise on Pluto, there is the same sunrise on Charon. Every shadow, every eclipse, is mirrored perfectly. They are cosmic mirrors, reflecting one another across a gulf of gravitational devotion. If one could listen to the music of their orbit, if gravity could hum, it would sound like the deep, resonant tone of stability. A note that has played for billions of years and may continue for billions more unbroken. And perhaps that is why, in every image of Pluto that stirs human hearts, Charon hovers nearby. The two cannot be separated, not in the sky, not in the imagination. Together they represent a truth the cosmos repeats over and over, that even at the edge of darkness, nothing truly travels alone. Before the dawn of the 21st century, before any spacecraft had ever glimpsed Pluto up close, there were the Voyagers, humanity's emissaries to the deep. Launched in 1977, their mission was to explore the outer planets, Jupiter, Saturn, Uranus, Neptune. They carried golden records inscribed with the sounds of Earth, our greetings, our music, our heartbeat, and as they voyaged outward, they became the first machines to slip beyond the boundary of sunlight's warmth. But they never saw Pluto. When NASA charted the paths of Voyager 1 and 2, it chose efficiency over curiosity. Voyager 1's trajectory was set toward a gravity-assist sling around Saturn that would send it north of the ecliptic plane on a route to interstellar space. Voyager 2's path bent southward, visiting Uranus and Neptune, a once-in-a-lifetime alignment that would not occur again for nearly 2 centuries. Pluto, small and misplaced on its tilted orbit, was left untouched, glimmering far from the spacecraft's roots like a forgotten candle at the edge of the map. The decision was practical, but history would remember it as poetic neglect. For decades, Pluto remained a point of mystery, unvisited, unseen. While Voyager's cameras revealed the volcanic scars of Io and the icy geometry of Europa, Pluto waited, patient and invisible, orbiting in the cold beyond Neptune's blue winds. And yet, the Voyagers did something profound for Pluto. They redefined what exploration meant. When their instruments detected magnetic fields around Jupiter and Saturn, when they discovered geysers and auroras on moons that should have been inert, they proved that the solar system was alive. They awakened curiosity for the outer darkness, preparing the stage for the moment Pluto would finally be approached. Each passing year, as the Voyagers drifted farther, Pluto's orbit carried it closer to the Sun, brightening slightly under the faint increase of light. By 1989, it reached perihelion, its nearest point to the Sun, in 248 years, and for the first time in human history, its atmosphere began to bloom. Telescopes on Earth detected gases escaping from its surface, forming a temporary shroud that glittered faintly against the void. The world that the Voyagers missed was stirring. Had either spacecraft been diverted toward it, the encounter would have been fleeting, a single flyby, a few blurred photographs, a whisper of data before fading into the dark. But perhaps, in their absence, something more meaningful occurred. Pluto was left to mystery, and mystery has its own gravity. For a generation of astronomers, the unvisited planet became a symbol of unfinished stories, of horizons still waiting. In the late 1980 and 1990 telescopes grew stronger, sharper. Adaptive optics and infrared detectors peeled away layers of distortion. Slowly, hints of Pluto's geography emerged: a bright polar cap, patches of shadow, signs of an atmosphere that came and went. But the details were beyond reach. Every image showed only a fuzzy, trembling disk. The world was there, but untouchable. For the scientists who had grown up watching Voyager's revelations, this void was intolerable. They had seen Neptune's storms swirl, Saturn's rings shimmer, Jupiter's lightning crackle through its clouds. Only Pluto remained unseen, a blank corner of the map, and for humans, blank spaces demand to be filled. By the 1990 seconds, murmurs began in conference halls and proposal meetings. It was time to go back, to finish what the Voyagers had begun. But each attempt faltered. Budgets were slashed, missions cancelled. Projects like Pluto Fast Flyby and Pluto Express were conceived and abandoned. For a time, it seemed that Pluto's fate was to remain forever imagined. Meanwhile, the Voyagers kept moving outward, slipping beyond the heliopause into true interstellar space. They carried their recordings of Bach and Chuck Berry, of greetings in dozens of languages, a testament to what humanity could make when it looked outward. And in their wake, they left a hunger for completion, a need to illuminate the final shadow. That hunger would give birth to new horizons. In the mid-2000s, when NASA finally approved the mission, it was framed as the spiritual successor to Voyager. The same spirit of adventure, the same instruments of curiosity, but this time, the target was the one that got away. It was as if the universe itself had kept Pluto waiting, preserving its secrets until technology and patience caught up. Voyager 1 is now more than 24 billion kilometers from the Sunday. It still whispers faintly to Earth, a signal weaker than a raindrop heard across oceans. In that distance, it has become an idea rather than a spacecraft, a symbol of leaving home. And every time its faint pulse reaches the deep space network, scientists remember that it once looked back on the planets we came from, and one day will drift past unknown worlds we will never see. Pluto might have been one of those worlds, but its absence from the Voyager legacy gave it a strange advantage. It became the mystery preserved in amber, the secret waiting at the end of the solar system's story. When the time finally came to unveil it, nearly 4 decades after Voyager's launch, humanity would see something far more astonishing than anyone could have imagined. Because in missing Pluto, Voyager ensured that the final revelation, the frozen heart, the blue haze, the mountains of ice, would arrive in a new century, under a new sky, at the perfect moment. In space, sometimes a mission is destiny. The Voyagers opened the way, and Pluto waited beyond their reach, the final verse in a song not yet sung. When New Horizons finally left Earth on the 19th of January, 2006, it carried within it more than instruments and cameras. It carried humanity's unfinished promise to Pluto. A small spacecraft no larger than a grand piano, it rode a column of flame from Cape Canaveral, accelerating faster than any craft before it. In just 9 hours, it passed the orbit of the Moon. Its destination lay billions of kilometers away, beyond the reach of sunlight's warmth, in a realm where time itself seemed to sleep. The mission had nearly not happened. For years, it had struggled through cancellations and budget cuts, surviving by the devotion of scientists who refused to let Pluto be forgotten. To them, this was not merely exploration, it was closure, the final act of a planetary story that began in 1930 when Clyde Tombaugh found a moving dot on glass plates in an Arizona observatory. Inside the spacecraft, a small vial of Tombaugh's ashes was secured with an inscription, "Interned herein are remains of American Clyde W. Tombaugh, discoverer of Pluto and the solar system's third zone." It was a poetic tribute. The man who had first seen Pluto's light would one day pass it. For nearly a decade, New Horizons sailed through the black. It slingshotted around Jupiter in 2007, gaining speed and capturing brief images of its storms and moons, a rehearsal for the grand encounter still years away. Then, after crossing the orbit of Neptune in 2014, it entered hibernation, drifting silently toward a point in space smaller than a pixel seen from Earth. To navigate such distance required precision beyond comprehension. Mission Control at Johns Hopkins University's Applied Physics Laboratory plotted its trajectory to intersect Pluto's position at a speed of 49,000 kilometers per hour. A deviation of even a minute would mean missing the planet entirely. Signals took over 4.5 hours to travel one way. Every command had to be pre-planned, every maneuver perfectly timed. And then, on the 14th of July 2015, New Horizons awoke to history. As it swept past Pluto at a distance of only 12,500 kilometers, its cameras captured what no human had ever seen: the face of a world once thought invisible. The data streamed back slowly, trickling through the void for more than a year. Each packet of information revealed another secret: the icy heart of Sputnik Planitia, the mountains of frozen water, the blue halo of its atmosphere. The first high-resolution image arrived on Earth and stunned the world. Pluto was not a featureless sphere of frost. It was a realm of contrasts: brilliant plains, jagged ridges, deep shadows, and that astonishing heart gleaming across half the planet's surface. The photograph became an instant icon. A billion years of isolation collapsed into a single human moment: the encounter between imagination and reality. Even the scientists who had waited decades for that image fell silent when it appeared. Many had expected cracks and craters, the inert scars of a world long dead. What they found instead was motion, vitality, designed landscapes younger than the dinosaurs, evidence of ongoing geological life. New Horizons instruments recorded nitrogen glaciers flowing across basins, frozen dunes shaped by faint winds, and mountain ranges of solid ice that defied logic. Its spectrometer detected variations in surface chemistry patches rich in methane and carbon monoxide, deposits that hinted at complex weather patterns. It found an atmosphere far more layered than models predicted, rising hundreds of kilometers into space and glowing with twilight. It was, as mission leader Alan Stern described it, a world of wonders, the most complex small planet we've ever seen. But the triumph was more than scientific. For humanity, it was a rediscovery of perspective. After decades of absence, Pluto was no longer an abstract point. It was tangible, a world with geography, history, and emotion. The images evoked a kind of cosmic empathy. In the solitude of that faraway heart, people saw themselves small, fragile, enduring. Over the following months, as the spacecraft continued to transmit its data, scientists pieced together Pluto's story. They mapped the circulation of its nitrogen atmosphere, charted the pattern of its haze layers, and modeled the convection cells of its icy plains. Each detail expanded the mystery. And as New Horizons drifted away, turning its cameras back toward the world it had just unveiled, it sent one final image: Pluto's silhouette against the backlit Sunday. The atmosphere glowed blue, encircling the planet like an ethereal halo. It was the image that would define the mission: not a world of darkness, but one of light. On Earth, millions watched as the images appeared online and on screens across observatories and classrooms. The excitement was not just for discovery, but for reconciliation. Pluto, long demoted and debated, had spoken again, and what it said was unmistakable. It was alive, beautiful, and worthy of wonder. New Horizons did not stop there. After passing Pluto, it continued into the Kuiper Belt, visiting another frozen relic named Arakoth, a contact binary that revealed the primordial nature of these distant worlds. The mission's instruments still function, still sending back whispers from the frontier. Pluto remains far behind now, shrinking into a bright dot among the stars. Yet in that brief encounter, New Horizons did something transcendent. It turned mystery into memory. It stitched together a narrative that began with a telescope in 1930 and ended with a spacecraft brushing past eternity. For the first time, the most distant known world was no longer a myth. It was a face pale, scarred, radiant, staring back at us through the void. When the last signals from New Horizons reached Earth, what they contained was nothing short of revelation. Pluto's surface, once imagined as still and ancient, told the story of a world that moves, that changes, that perhaps still reshapes itself even now. Each new image arriving through the deep space network was a postcard from the frontier, depicting patterns no one had expected: glacier-like flows, vast nitrogen plains, and hints of mountains that might once have erupted in cold fire. The data revealed something deeply unsettling and deeply beautiful. Pluto might not be geologically dead. Scientists studying the region west of Sputnik Planitia saw signs of activity that could only be explained by movement beneath the surface: frozen nitrogen creeping across basins, forming ripples and ridges as it refroze. These slow flows, measured over millions of years, looked startlingly similar to the glaciers of Earth. Except here, the ice was not water, but nitrogen, moving like honey across the frozen terrain. Elsewhere, vast dome-like features rose from the plains, some nearly 7,000 meters tall. They were broad, circular, and strangely textured, lacking the crisp edges of mountains formed by impact or compression. Many geologists believe these are cryovolcanoes, volcanoes that do not erupt molten rock, but slurries of water, ammonia, and methane, spewing material from deep within Pluto's interior. Two such features, informally named Wright Mons and Piccard Mons, dominate the southwestern region of Sputnik Planitia. Both are immense. Their bases span hundreds of kilometers. They seem geologically young, unmarred by craters suggesting eruptions in the recent cosmic past, perhaps only a few 100 million years ago. The notion stunned scientists. On a world so small, so cold, how could enough energy remain to fuel such forces? The answer, once again, may lie in Pluto's mysterious core. Beneath its crust of nitrogen and methane, a rocky heart smolders with the residual warmth of radioactive decay. It is faint, but it is constant. Over billions of years, that energy could keep water deep below in a liquid state, creating a reservoir of motion beneath the ice. As heat slowly seeps upward, it could drive cryovolcanism, pressurizing subsurface water and ammonia until it finds cracks in the crust, erupting gently across the surface. The frozen domes that remain are like exhalations, breaths from a hidden ocean trying to speak through ice. Each observation from New Horizons fed this idea further. The spacecraft's instruments measured subtle differences in surface composition, detecting ammonia hydrates and water ice concentrated around these mysterious domes. These are the fingerprints of internal activity, as if Pluto's buried ocean, long confined, had found ways to reach the light. Even the surface textures told a story of recent renewal. The plains of Sputnik Planitia are remarkably smooth, suggesting a surface no older than 10 million years, a heartbeat in geological time. Craters, the usual markers of cosmic age, are rare. Where others exist, they often look softened, eroded by sublimation or buried under new frost. Pluto's face, it seemed, was still being rewritten. The discovery forced planetary scientists to rethink their assumptions about small, icy worlds. They had long believed that geological activity required massive-size worlds, large enough to retain heat, or generate internal friction through tidal forces. But Pluto defied that rule. It was too small, too cold, too distant, and yet it moved. Alan Stern and his team called it the most complex small world ever explored. Its landscapes contained nearly every process known to planetary geology: erosion, convection, glaciation, tectonics, and possibly volcanism, all operating in slow motion at the edge of the sun's light. The implications stretched far beyond Pluto. If such activity could exist here, in a world this small, then the Kuiper Belt itself might be filled with hidden engines, worlds that breathe and flow beneath their icy shells. Life, or at least the chemistry that leads to it, could be more widespread than anyone imagined. In the wake of New Horizons discoveries, planetary scientists began to use a new language to describe Pluto. It was no longer simply active or alive, it was self-regulating. The cycles of freezing and sublimation, the slow creep of glaciers, the faint heat within its heart, all of these acted together to maintain equilibrium. Pluto was not static, it was in conversation with itself. This realization gave rise to haunting new theories. Some suggested that Pluto's hidden ocean could still interact with its icy shell, feeding cryovolcanoes that occasionally burst through. Others speculated that complex organic chemistry, stirred by the faint warmth below, could be forming prebiotic molecules. The boundary between geology and biology blurred in the imagination. And yet, even without life, Pluto exhibits something like vitality, the restless motion of matter against the pull of entropy. It is not the heat of stars or the chaos of storms, but the quiet persistence of slow transformation. Its surface glimmers with frozen nitrogen, its ridges breathe methane vapor, and its plains shift under the weight of gravity and time. Every new model, every image, paints a portrait of endurance. Pluto should have gone still billions of years ago, yet it remains in flux like a faint ember refusing to die. If one were to stand at the rim of Sputnik Planitia and look out across its smooth plains, one would not see the violence of volcanoes or the force of tides. Instead, one would witness serenity, an alien calm born of continual renewal. Beneath that silence, slow forces churn, patient and invisible. It is as though Pluto has mastered a kind of cosmic meditation, existing not in decay but in perpetual becoming. And somewhere deep within that stillness, the data whisper, there may yet be an ocean, an ancient, hidden sea waiting beneath the ice. If Pluto's surface hinted at motion, its interior whispered of something even more profound: an ocean. Not an ocean of blue waves or currents, but one buried beneath kilometers of ice, sealed in darkness for billions of years. To the untrained eye, the idea seems impossible. How could a world so small and cold harbor liquid water? And yet, the evidence gathered by New Horizons has led many scientists to believe that beneath the frozen plains of Sputnik Planitia lies a vast subterranean sea, a reservoir of warmth and memory, still stirring at the edge of the sun's reach. The first clue came from gravity itself. As New Horizons mapped Pluto's mass distribution, scientists noticed something peculiar. Sputnik Planitia, the great heart-shaped basin, seemed to be unusually heavy. This was strange, because the basin is a depression, a dent, that should be lighter, not denser, than its surroundings. The only plausible explanation was that something beneath it was denser than ice, perhaps a layer of liquid water, or even an ocean that had sloshed upward beneath the crust. Computer models deepened the mystery. If such an ocean exists, it would need insulation, a way to trap heat for billions of years. Pluto, surprisingly, provides it. Its outer shell, made of nitrogen and methane ices layered atop water ice, acts like a cosmic thermos. Beneath that shell, the decay of radioactive elements in Pluto's rocky core produces a faint but steady warmth. over eons, that heat could keep an inner ocean from freezing entirely, even as the surface remains locked at 230 degrees Celsius. In this world of paradoxes, water behaves like rock and ice behaves like air. The boundaries blur. Scientists imagine this hidden ocean as a global layer, perhaps 100 kilometers deep, sealed under a crust that flexes and shifts as internal heat ebbs and flows. The base of Sputnik Planitia, they believe, may be thinner than elsewhere, a place where the ocean pressed closest to the surface, perhaps even touching it in ancient times. If this ocean exists, it changes everything. It would mean that Pluto, though smaller than Earth's moon, shares kinship with other ocean worlds, Europa, Enceladus, Titan. Each of these bodies, though encased in ice, hides liquid water beneath their surfaces, and with water, the possibility of chemistry that echoes life. Life, as we know it, needs three things: water, energy, and complex molecules. On Pluto, all three might coexist in subtle equilibrium. The ocean would provide the medium, radioactive decay, the energy, and the surface tholins, organic compounds built from carbon, hydrogen, nitrogen, the building blocks. No one dares claim that life exists there, but the idea is haunting. In the deep and ancient dark, far beyond the warmth of sunlight, there could be currents where molecules drift and assemble, where chemistry dances slowly toward the edge of biology. It would not be a life of light and air, but of patience, a life that measures time in millennia. The speculation does not end there. Some scientists believe Pluto's ocean could have once connected to its surface through cryovolcanic vents, frozen geysers that erupted from fractures, releasing slurries of water, ammonia, and methane that later refroze as domes. If true, then pieces of Pluto's hidden sea lie frozen in plain sight, written into the ice of Wright Mons and Picard Mons. Each eruption would have been an act of renewal, an ocean exhaling into the void. In these theories, Pluto becomes more than an inert sphere. It becomes a living system of exchange, where the deep and the shallow, the cold and the warm, constantly converse. The ice shell above the ocean could move slowly over time, thickening and thinning with the planet's orbit. And as Pluto drifts farther from the Sun, its internal warmth may cause the ice to crack and shift, perhaps even allowing small plumes of vapor to escape. If such plumes exist, they would rise and freeze, sprinkling fresh frost across the surface, a cycle of respiration on a planetary scale. It is tempting, too, to see metaphor in this science. The idea of a hidden ocean beneath an icy heart mirrors something deeply human, that even the coldest exteriors can conceal depth and warmth within. In Pluto, we glimpse the universe's talent for contradiction, a frozen world that may cradle a sea, a dead planet that refuses to stop moving. Future missions, perhaps orbiters equipped with radar and spectrometers, may one day confirm the existence of this buried ocean. For now, it remains a hypothesis supported by indirect evidence, gravity anomalies, tectonic scars, and computer models that whisper of warmth. But even unproven, the ocean changes how we imagine Pluto. It shifts the narrative from isolation to connection, from a barren world to one that shares in the solar system's hidden aquatic legacy. If water can persist here, at the edge of space, then the conditions for complexity are far more resilient than once believed. In a way, Pluto's ocean becomes a message that life's raw materials need not bask in sunlight to endure. They can wait, suspended in darkness, listening for the faint pulse of heat that says not yet frozen, not yet gone. It invites a philosophical question, one that has haunted astronomers for generations. What if the universe is not empty, but merely slow? What if, in places like Pluto, creation moves not at the speed of light, but at the pace of patience? When scientists gaze at Pluto's icy heart, they do not just see a world, they see a mirror of endurance. A reminder that even in the farthest reaches of night, something still moves, still warms, still waits. And perhaps, beneath those kilometers of silent frost, an ocean still whispers not loudly enough to hear, but enough to remind the cosmos that it has not yet fallen completely asleep. Beyond Pluto's orbit lies a frontier vast enough to humble imagination, the Kuiper Belt. It stretches like a ghostly halo around the sun, a realm of relics left over from the solar system's formation. In this frozen wilderness, billions of small worlds drift through darkness, icy fragments, primordial debris, the building blocks that never became planets. Pluto is its crown jewel, not an exile from the inner system, but a messenger from this far frontier, carrying within it the chemistry and memory of creation itself. When astronomers discovered the Kuiper Belt in the early 1990 seconds, it changed everything. Until then, Pluto had seemed like a strange misfit, the oddball at the edge of the planetary family. But suddenly, it made sense. It was not alone, it was one of many, a survivor among countless frozen siblings orbiting the Sun beyond Neptune. The mystery of its tilted orbit, its small mass, its icy composition, all these traits became not anomalies, but signatures of its true home. The Kuiper Belt is a fossil record written in ice. It preserves the ancient materials that once swirled in the disk from which the planets formed. Closer to the Sun, these ices melted and coalesced into rocky worlds. Farther out, they froze and remained untouched for billions of years. To study Pluto is to study the dawn of the solar system, to hold a mirror up to time itself. New Horizons did not stop at Pluto. After its historic flyby, it continued deeper into this region, visiting another object known as Arakoth, a contact binary shaped like two spheres fused together. Arakoth, whose name means sky in the Powhatan language, became a time capsule of formation, its untouched surface showing that gentle collisions, not violent impacts, built the first worlds. The same quiet process may once have formed Pluto, aggregating dust and ice into a body large enough to hold its own gravity, to grow a moon, to evolve an atmosphere. In this context, Pluto becomes less an outlier and more a masterpiece, a rare glimpse of what the solar system might have looked like before chaos took hold, before planets migrated and moons collided. Its composition, a mixture of rock, water, ice, methane, and nitrogen, matches the chemistry predicted for the earliest building blocks of the outer planets. But Pluto's story carries an additional twist. It did not remain where it was born. Many models suggest that early in the solar system's history, Neptune migrated outward, its immense gravity scattering Kuiper Belt objects into new orbits. Pluto may have been among them, caught in resonance with Neptune, locked in a 32 orbital pattern, where for every 3 trips Neptune makes around the Sun, Pluto makes 2. This celestial choreography has lasted for billions of years, keeping the two worlds in a gravitational dance that prevents collision, even though Pluto's path crosses Neptune's. This resonance is a relic of cosmic migration, a faint echo of the violence that shaped the solar system's outer edge. The Kuiper Belt, then, is not a place of stillness, but of aftermath. Its objects, including Pluto, are survivors of upheaval, fragments of the original solar nebula flung outward and frozen in their orbits. Every discovery from this region deepens the enigma. Some Kuiper Belt objects, like Haumea and Makemake, share Pluto's icy composition but spin with wild speed or possess thin atmospheres of their own. Others, like Eris, rival Pluto in size and reflectivity. These worlds, too, orbit in slow procession around the Sun, each bearing clues to how planets once formed and how they might form elsewhere. Pluto, though, remains unique. Its binary relationship with Charon, its varied terrain, Its atmosphere that breathes all make it a kind of bridge between the small, inert rocks of the Kuiper Belt and the great planets of the inner solar system. It is both relic and revelation, an ambassador of two worlds. Scientists studying Kuiper Belt dynamics often speak of Pluto as the gateway object. It is the most accessible representative of its class, a frozen witness to conditions that predate Earth itself. Its surface chemistry reveals how organic compounds evolve under cosmic radiation, how volatiles migrate and freeze, how ice and rock can shape themselves into continents and glaciers even in the absence of sunlight. But beyond the data, the Kuiper Belt offers something intangible, a philosophical echo of the infinite. Here, at the edge of our sun's dominion, the rules of familiarity dissolve. Days stretch for centuries, seasons for millennia. The sun shrinks to a star among many, and light becomes something that must be cherished. To look outward from Pluto is to look into the abyss of beginnings, a space both ancient and newborn. These are the remnants of creation, untouched since time's first frost. And somewhere beyond them, in the unseen Oort cloud, lie the seeds of comets that may one day return to the inner system, carrying whispers of their birthplace. Pluto's role is thus both scientific and poetic. It reminds us that the universe is not linear, not arranged in neat hierarchies of importance. The outskirts are as vital as the center, the forgotten as meaningful as the famous. In the Kuiper Belt, the cosmos preserves its memories frozen, waiting, eternal. The spacecraft that visited Pluto now drifts through that region, its instruments still awake, listening. It measures dust, counts particles, records faint glimmers from unseen worlds. It sails through the primordial haze, not in search of planets, but in search of origins. And so, Pluto becomes both a world and a witness. It holds within its frozen crust the chemistry of early time, the echoes of ancient collisions, the fingerprints of cosmic birth. It is no longer the ninth planet. It is something far older, a survivor of the first light, a messenger from the age when stars and planets were still learning to exist. To gaze upon Pluto is to see the handwriting of creation faint, cold, but still legible after 4.5 billion years. Beyond Pluto, light becomes a rumor. The sun, once the blazing heart of everything we know, shrinks to a pale, steady star, its warmth barely distinguishable from the chill of the cosmic background. Here, at the edge of its dominion, energy fades into memory, and day and night lose their meaning. It is not darkness in the way we know it on Earth. It is the absence of dawn. This is the realm that Pluto calls home, the edge of light. It moves through this region with silent precision, its orbit elongated and tilted like the arc of a distant pendulum. For most of its 248-year journey, it inhabits this half-lit world, caught between the dying rays of the sun and the eternal shadow of interstellar space. At this distance, the sunlight is 1,600 times weaker than on Earth. Shadows fall not in blackness, but in deep blue-grey. The sky is neither dark nor bright. It glows faintly, illuminated by reflected light from Charon and by the ghostly sheen of the Milky Way. Time itself feels slower here, stretched by distance, measured not in days but in centuries. Physicists often describe Pluto's domain as a threshold, a boundary between gravitational belonging and cosmic independence. It is still part of the Sun's empire, but barely. Beyond this point, the Kuiper Belt gives way to the scattered disk and, farther still, the Oort cloud, a vast spherical swarm of comets that extends halfway to the nearest star. This is the frontier where the solar system dissolves into the galaxy. And yet, even here, where light is fragile and heat almost gone, the laws of physics remain steadfast. Gravity binds, light bends, chemistry endures. There is no chaos, only subtlety. Everything moves slowly, precisely, with the patience of eternity. To stand on Pluto's surface, if one could withstand the cold and the thinness of its air, would be to experience the most profound silence in nature. The sun, a pinprick of gold, would cast long shadows over the crystalline plains of nitrogen ice. The stars would be so numerous that they would merge into a silver mist across the sky. Charon would hover motionless overhead, locked in eternal gaze, while the Milky Way arched like a frozen river. From this vantage point, Earth would be just another point of light, a faint blue dot indistinguishable from the others. Every ocean, every life, every sound that has ever been, contained within a single flicker lost among the stars. Pluto invites reflection on the nature of perception itself. The further we travel from the sun, the more our sense of reality shifts. Concepts like day, season, temperature lose their relevance. Even time behaves differently here. Einstein's equations predict that clocks tick more slowly in weaker gravity, a small effect near Earth, but magnified over cosmic scales. In a sense, Pluto exists in an older rhythm of time, moving at the tempo of the universe rather than the pulse of humanity. For astronomers, this threshold between light and dark is both terrifying and sacred. It marks the boundary of the known, a place where measurement gives way to imagination. Beyond Pluto, even light begins to fail us. Telescopes must infer more than they see, data becomes memory, signal becomes whisper, and yet, from that whisper, we build meaning. It is here that science turns philosophical. Why do we seek the edge? Why do we send our fragile machines into a void that cares nothing for us? The answer lies not in discovery, but in reflection. To understand Pluto is to understand ourselves, our hunger for perspective, our need to know what lies beyond the next horizon, even when that horizon offers only silence in return. In Pluto's world, distance is destiny. Every orbit, every shift of frost, every slow exhalation of its breathing atmosphere is governed by the faint pull of a sun so far away it feels like memory. It is a planet, or something like one, that teaches humility by its very existence. It does not revolve in service of our categories or definitions. It simply is, drifting through a landscape where even the concept of light becomes a philosophical question. The light that reaches Pluto has traveled for hours, sunlight, aged by distance, weakened by space. Each photon that lands on its surface has journeyed 6 billion kilometers, brushing through solar wind and cosmic dust to strike nitrogen ice and scatter into faint bluish glow. Every glint of that light, caught by the cameras of New Horizons, is a message from the sun that has taken half a day to arrive. In that delay is a metaphor for human understanding. Knowledge, like light, travels slowly. It fades, it distorts, it takes time to reach the outer edges of what we can comprehend. But when it finally arrives, when a distant world lights up in our awareness, it changes everything. Astronomers sometimes call Pluto the mirror of isolation. It reflects not just sunlight, but our longing, our need to find beauty even in desolation. Its heart-shaped glacier, gleaming faintly under a dying star, seems almost to console us. You are not alone in your loneliness. Beyond this edge, space stretches into interstellar night, where the sun's light becomes indistinguishable from every other star's. Here, the universe ceases to feel like a home and begins to feel like an ocean, vast, cold, infinite, indifferent, yet filled with meaning precisely because we dare to sail it. Pluto is the shoreline of that ocean. It stands as both ending and beginning the last familiar landmark before we lose ourselves in the galaxy. And as the sun sets over its distant horizon, scattering the last threads of gold through the thin haze, one might imagine the silence whispering the oldest truth of all that light. No matter how far it travels, never truly disappears. Pluto drifts on, unhurried, along its long elliptical path, a patient pilgrim in a cosmic orbit that will outlast every living memory on Earth. Around it, the stars remain fixed and eternal. Its faint blue atmosphere breathes softly, expanding and collapsing as the centuries turn. Beneath that fragile veil, its icy heart gleams with a light that will never reach us, unaided, a silent pulse in the farthest corner of the solar system. From this distance, even human history becomes a flicker. When Pluto completes its next orbit, nearly 25 decades from now, the world that discovered it may no longer exist. Yet Pluto will persist, indifferent to definitions and names, circling the sun as it always has, slowly, faithfully, beautifully. It is a place of paradoxes, of stillness and motion, the ice mountains of water, immovable yet eroding, the glaciers of nitrogen, flowing though frozen, the hidden ocean below, suspended between solid and liquid, past and present, its moon, Charon, forever locked in gaze. Together they turn, two halves of a cosmic duet repeating endlessly in the dark. The deeper science looks into Pluto, the less it resembles the cold, inert body once imagined. It is alive in the only way a world can be alive, through change, through persistence, through the quiet defiance of entropy. Its surface rewrites itself over ages, its heart convects, its breath drifts skyward and returns as frost, and somewhere, deep beneath the crust, an ancient warmth still stirs. Pluto, the exile, the outcast, the downgraded, has become the universe's quiet philosopher. It asks questions rather than answers them. What does it mean to belong, to exist beyond warmth, yet still move, still evolve? It suggests that life, or at least vitality, does not depend on classification, nor even on sunlight. It is written into the nature of being itself, the tendency of matter to organize, to resist stillness, to find meaning in persistence. To gaze upon Pluto is to feel the passage of cosmic time. Its landscapes have seen the birth and death of species, the rise and fall of stars. The very light reflecting from its surface tonight left before many of us were born, and still it shines back, indifferent to our categories, radiant in its solitude. The discovery of Pluto once expanded the map of our solar system, but what New Horizons revealed expanded something far more profound: our understanding of humility. To see this small, distant world up close was to remember that significance is not measured in size or power, but in endurance. The universe does not reward the bright and the large, it cherishes the persistent. Even now, as New Horizons continues its voyage beyond, sending faint signals from the Kuiper Belt, the images of Pluto endure in human imagination. The world that was once a myth, then a planet, then a question, is now something timeless, a symbol of what it means to reach outward, to seek meaning even in the cold. It reminds us that curiosity, like gravity, is universal. It binds us to the cosmos as surely as any orbit. And though the universe may seem silent, each discovery is an act of communication, a call and response between the human spirit and the infinite. Pluto's story is not one of loss, but of reclamation. It was never truly dethroned, only redefined. Its mystery remains intact, perhaps even deepened by its distance from our grasp. In the hierarchy of the planets, it may have lost its crown, but in the mythology of wonder, it reigns eternal. When scientists look at it now, they see not an exile, but an ambassador, a world that carries the whispers of creation and the promise of endurance. Its frozen plains and spectral haze remind us that the edge of the known is not the end of meaning, but the beginning of reflection. At the heart of that distant world lies Sputnik Planitia, shining like a beacon against the void. It is not just a glacier, it is a symbol. a frozen heart that beats so slowly that a single pulse may last eons, yet beats nonetheless. Pluto is not the end of the solar system, it is the beginning of awe. And now, the journey quiets. The spacecraft drifts onward, its signal dimming, its memory full of frozen sunlight and blue haze. Behind it, Pluto recedes into the eternal night, shrinking to a faint shimmer against the black sea of stars. The light that once revealed its face will keep traveling through interstellar dust, through ages of silence, carrying with it a story of patience and discovery. In that silence, there is peace. The mountains no longer rise, they wait. The nitrogen plains no longer flow, they dream. Charon still hovers above the horizon, casting pale light across the plains. And deep below the ice, if the theories are true, an ancient ocean still turns in its sleep. The sun, a faraway ember, will continue to rise and fall, a slow heartbeat of gold on the edge of forever. Seasons will come and go. Across Pluto's frozen world, centuries of night followed by centuries of pale dawn. Time itself will become circular, like the orbit of the planet that never stops moving. Perhaps, one day, another traveler will pass this way. It will find Pluto, as New Horizons did, quiet, dignified, eternal. And it will find, in that frozen heart, a reflection of its own purpose, to wander, to learn, to listen. For now, the light fades, and the music softens. The story of Pluto, the world of shadows and ice, becomes a whisper in the grand narrative of the cosmos. The mystery remains, suspended in the endless cold, serene, luminous, patient. And as we drift toward sleep, we remember even at the farthest edge of sunlight, wonder endures. Sweet dreams.